In question 2.3, we've been given two trig equations. We've been told that k is greater than 0. And now we need to explain why beta lies between 270 and 360 degrees. Okay, to pull this off, we're going to have to isolate sine beta and cos beta. And when I say isolate, it's just a fancy way of saying get sine beta on its own. So over here, we're going to have to divide both sides by k to get it on its own. Over here, we're going to need to move the 1 over and then divide by k. And while we're analyzing the question, you see this k is greater than 0? That's like a really fancy way of telling you that k is positive. So if you convert that to English, it's a very powerful tool, and we are going to need that to crack this question. Okay, so let's isolate these guys. Let's start off with the sine. And as discussed earlier, to get sine on its own, I'm going to divide both sides by k. And then those k's cancel, and I'm left with sine beta equals minus 5 over k. Okay, now it's the cos's turn to get chisenyonked, my friend. Let's grab him and manipulate. Okay, now to isolate cos beta over here, I'm going to take that minus 1 over, and it becomes plus 1. And 0 plus 1 is just 1, so we get k cos beta equals 1. I then divide both sides by k, and then the k's on the left hand side cancel, and I'm just left with cos beta equals 1 over k. And now what I'm going to do is analyze these statements and use my cast diagram to explain why beta is sitting in between 270 and 360. So let's grab our cast diagram. So when I analyze this statement, if I look at k, we discussed earlier that they told us k is positive. So I know k is going to be positive. And if I look at the top, it's negative. It's negative 5. So if I have a negative divided by a positive, the overall result will be a negative. And now we know that sine beta will be negative. So we have a look at the cast diagram and we ask ourselves, where is sine beta negative? So it's positive here, so it has to be negative in these two quadrants. And I like to put little ticks in those quadrants just to keep track of where sine beta is negative. And bear in mind, you don't have to write sine beta is negative. You can write it more mathematically like this. You can say sine beta is less than 0. But I prefer the previous one, it just makes more sense to my brain. Okay, now it's the cos's turn to get chisenyonked, my friend. Alright, k is positive, as they told us earlier in the question. And then that 1, it's also positive, there's no negative there. So a positive divided by a positive will give us a positive number. And with that, we can conclude that cos beta is positive. So we look at our cast diagram and we ask ourselves, where is cos positive? They are all positive in the first quadrant, so it will be positive there. And cos is positive in the fourth quadrant, so it will also be positive there. And now I have to choose the quadrant that meets both conditions. And that's quadrant 4, which is in between 270 and 360. So how we're going to wrap this up is like so. We firstly need to state that sine beta is negative and cos beta is positive in quadrant 4, as we discussed earlier. And then we wrap it up with a nice bow and say beta is an element that spans between 270 degrees and 360 degrees. And let's quickly have a look where the 4 marks come from. Okay, you get a mark for isolating cos, a mark for isolating sine, then isolating cos, a mark for a diagram, and a mark for your explanation. Next up, we are asked to determine the value of tan beta. And to do that, we're going to need to grab these guys. So I'm going to grab those two quickly. And I'm also going to need my classic SOHCAHTOA. Okay, so for sine, that's the opposite over the hypotenuse. So I know minus 5 is the opposite, and I know k is the hypotenuse. And if I analyze cos in the same fashion, we can see our hypotenuse, it agrees with the sine, and then the top one will be adjacent for cos. And now if I want to get tan of beta, on top, I put the opposite. So on top, where's the opposite there? -5. We're going to put -5 on top. And then at the bottom, I'm going to put the adjacent. There's the adjacent. It's 1. And then -5 over 1 can simplify to -5. So there's tan beta. It's -5, my bro. And wrapping up 2.3, we are asked to determine the numerical value of k without using a calculator. So we're going to have to do some Pythagoras to pull this off. And to actually understand what you're doing, I'm going to draw the diagram for you. You don't have to, but it's good to see it in your head. And just in case you're curious on how we're going to draw this. So we discussed earlier, we're going to be working in quadrant 4 in between 270 and 360. Then we know the hypotenuse is k, so I'll just put a k by the hypotenuse. And I know it's the hypotenuse because that 90-degree angle is pointing towards it. And then across from our reference angle, or opposite to our reference angle, is the -5. So we chuck that there. And then adjacent to the reference angle, will be the 1. And that's how we draw our sketch. And now to find the value of k, I've got to do Pythagoras. So let's grab the Pythagoras theorem. So a hypotenuse always comes first. The hypotenuse squared equals the sum of the other two sides squared. So the hypotenuse is k. So I'm going to change this h to a k. And then it doesn't matter which one I put into a or b. It'll give me the same result either way. I'm just going to grab that one and put it in a's place, which leaves -5 to go into b's place. And just remember your brackets, very important. Alrighty, so 1 squared is just 1. I keep the plus there. -5 times -5 is +25. So I'll just get a 25 there. 1 plus 25 is 26. And then to get rid of that square, I square root both sides. And then I get k to be the square root of 26. We should get plus minus root 26. But a small rule with sketches is the hypotenuse is always positive. So we always choose the positive one. And then let's have a look where the 2 marks come from. First mark comes from substitution into Pythag. Second mark comes from the final answer.